Hey guys, this is a free lesson on solving formulas that contain squares or square roots. So we're going to be looking at problems that are formulas like this. So all these different types of problems, we're going to talk about how to solve for them. So as a reminder, the way these videos work, you want to pause and try the examples when you are prompted to do so, and there are always free guided notes available. I highly recommend that you take notes alongside this video. It will help you retain it better. Also, if you could just do me a big favor, like my video, subscribe and share my channel, and comment if you have any suggestions or if you found this helpful. Just kind of give me a little bit of feedback. I would appreciate that. I'm trying to bring as much free math help and instruction onto the internet as I possibly can. Okay, so let's get started here. So let's start out with solving for formulas that have squares in them. So in this formula, I'm asking you to solve for x, and you'll notice x here is squared. So what you want to do first is you want to isolate the squared term. So in this case, what I want to do then is I have to kind of whittle away at this, and this is a fraction. So in general, when you have a fraction, then what you're going to want to do is you're going to want to get rid of that. So you can just multiply both sides by z, and you will get rid of that. So now I've got zy equals 4x squared. So let's continue to isolate the x squared. So let's go ahead and divide out the 4 from each side. So I'll divide out the 4. And now I get x squared equals zy over 4. So now I can go ahead and take the square root of each side, and I have to use the square root property. So this will be kind of the thing when you have squares in them, you're going to use the square root property to help you finish it. So I'll just note that over here. So when I do that, I take the square root of each side, and this side will be plus or minus. So now I get x equals plus or minus the square root of zy over 4. Now, depending on the class that you're in, this format may or may not be okay. Now, if you're one of my students, this is not okay. You're going to have to simplify this as far as possible. It's because I'm mean, of course. So you cannot have a fraction under a radical. That's kind of a general rule. But notice that you can totally take the square root of the bottom. So this would equal x equals plus or minus, and this would just be the square root of zy over the square root of 4, and the square root of 4 is just 2. So maybe I'll just note that here. So the square root of 4 equals 2, so then that will go over there. So you want to make sure that you do not have a fraction under the radical and that there is no denominator here. So what that means is you might have to rationalize the denominator. Just a heads up on that. Okay, so here are 2 for you to try, and you can hit play when you're ready. So first things first, I have to isolate the k, or really the k squared. And the k squared right now is in the denominator, so you still just want to get rid of the fraction. That's just a best practice thing. So once you get rid of the fraction, now notice what you've got. You've got x squared, or k squared b equals 3, and I'll keep working towards isolating that k squared, so I'll divide both sides by b. So now I get k squared equals 3 over b. And now I can use the square root property, so I can take the square root of each side. And so in the end, I get k equals plus or minus, so this is the square root of 3 over the square root of b. So this one's going to be one then where you can't simplify the square root of b any farther, so this guy's got to be rationalized. Now, to rationalize this, you just have to multiply the top and bottom by the square root, just like this. So then in the end, what I get is k will equal plus or minus the square root of 3b, all of that over b. And then that would be your answer. So that's just something that you're going to have to look out for. So keep that in mind as you try this next one. So once again, I need to get to a. So I have to get rid of the fraction again. So let's just start by, we'll just multiply both sides by 2. So that will cancel out my fraction. So now I get 2b equals a squared c, and then I'll just divide out the c so I can get to the a squared all by itself. So now if I take the square root of each side, so notice what I get. I have plus or minus the square root of 2b over the square root of c, and once again I'm going to have to rationalize. So to rationalize, I'll just go ahead and multiply the top and bottom here by c. So now I get a equals plus or minus the square root of 2bc over c. So that's what you're going to have to watch out for when you are solving things that have squares in them. So now let's pivot to working with things that have square roots. So I think this is actually a little bit of a simpler case in some ways because you won't have to rationalize. So in this case, the goal here, so I need to solve for b, but if your variable is covered in a square root, then you need to get rid of the square root. So what I have to do then is I have to just square both sides, and that will get rid of the square root. So maybe I'll just note that here. So now I get a squared equals b over c. And since I'm just solving for b in this case, this is actually a much simpler problem than what we were dealing with before, because I don't have to worry about now taking a square root and rationalizing and all that. So I just have to get rid of the fraction. So I multiply both sides by c. Those c's will cancel out. And then I'm just left with b equals ca squared. And that's actually it. You don't have to do anything else. So why don't you pause the video and try these two and then hit play when you're ready. I've told you the variable to solve for. Okay, so for this one, so once again, so I'm just going to start by squaring each side. So now I get x equals 3y over z. And so best practice, you want to just get rid of the fraction. So I'll go ahead and multiply each side by z to get rid of the fraction. And now I have a much clearer picture of what I'm trying to do here. So I'm trying to solve this for z. There is my z, so I can just divide both sides by x. So divide each side by x, and I get z equals 3y over x. And so that will be your solution here. Okay, and so for k, it's going to, so we're solving for k now. It's still the same idea, right? So I'll start by squaring each side. So I get m squared equals nk over 3t. And so now you need to basically just whittle away to get to k. So first get rid of the fraction. So to get rid of the fraction, you'll multiply both sides by 3t. And so now I have nk equals 3t m squared. So I remember now, like some of the trick here is to remember what letter are you actually solving for. I'm trying to solve for k, so now to get the k by itself, you want to divide both sides by n. And so now I get 3t m squared over n. And so that's all I have to do for that one. Okay, so now let's pivot to another problem type. So I need to solve for x on kx squared plus cx minus d equals 0. So take a good look at this and just notice what makes this a little different from what we were doing before. We still have x squared here, but the thing that's different from the other problem is that we also have just a regular x, so x squared and then x. So we have two occurrences of x here. So if you just take a moment to think about it, you might notice that this looks very similar to what? It looks just like a quadratic. So since it's quadratic, what could you use since we don't know how else to really solve this? Quadratics, we can normally take like factor, or we can complete the square, or we can use the quadratic formula, or we could use the square root property. We have lots of things. But just in looking at this, I can't factor this. I don't know how to factor this. The square root property would just be kind of annoying. So this is a quadratic equation, so we can use a quadratic formula. So now what you have to do here is you have to identify what is your a, b, and c. So in the a position, I have a k. In the b position, I have a c. And then in the c position, I have a negative d. So it's maybe a little bit dizzying. So let me just write out the quadratic formula real quick for you. So let me write that in one color. Okay, and so now what I want to do is I just want to take each one of these letters and plug in this respective other letter. So first just plug it in, try not to overthink it too much. So now where I have this negative b, now I'm going to write it out as negative c, and then this is going to be c squared minus 4 times k times negative d. So we're just plugging everything in, and then all of this times 2k over 2k. So now that you've gotten to this point, now it's a matter of just seeing, is there anything that you can actually simplify? Maybe you can, maybe you can't. And if you look at this, really the only thing you can simplify is you've got a negative times a negative here. So the final answer is going to look a little goofy, but it's going to be c squared plus 4kd, all of this divided by 2k. And you can't simplify this any farther because you're not allowed to just break up. Since this is all being added under here, you can't just take the square root of c squared. If this were something like the square root of 4c squared, this you can do, but you cannot do the square root of 4 plus c squared. That's not a thing. So just something to kind of keep in mind. And that's basically it. So you're going to plug in everything and then just see what, if anything, you can simplify. Okay, so now why don't you pause the video, hit play when you're ready, and solve for these two. Okay, so now if I work through this, I need to solve this for b. So what's in my a position is a. What's in my b position is -5, and what's in my c position is the m. So if you're getting thrown off with this, remember, for a quadratic equation, quadratic equations have this form ax squared plus bx plus c equals 0. So notice you have to take a second, and I know there's a lot of letters here, and that can definitely make this very challenging. So when you look at this, just notice what is playing the role of x in this particular equation. So the b's, we are pretending those are the x squareds. So the numbers or letters in front of the b's are what's going to actually be selected for our quadratic equation. So that's the idea behind this. So now let me go ahead and plug all of these things into our quadratic equation. And so once again, it's just a matter of seeing what can you actually simplify. So here I've got a double negative here, so this will become positive, and then I can square this, and there's not really a lot else I can do. So my final answer will be 5 plus or minus the square root of 25 minus 4am, all of that divided by 2a. And so that's it. Okay. So now for this last one. So now I need to solve this for k. So notice I've got the k squared and I've got the regular k here. So now you have to identify what's in the a, b, and c position. So for this one, my a is 1/2, my b is all of this -5n, and then my c is m again. So now I can plug this in. So I'll go ahead and do that. Okay, so now this is what I'm left with. So once again, it's just what can I actually simplify? So once again, I got the double negative here. I need to square this, and I need to multiply kind of these pieces out. So in the end, I'm going to get k equals 5n plus or minus the square root. So -5n squared, that'll be 25n squared. And then 4 times 1/2 is 2, so this will be ultimately minus 2m. And then over 2 times 1/2 is just 1. So you actually could just write all of this without a denominator if you wanted. Or you could write all of this over 1. Tomato, tomato in my eyes, but you know, some people might care about it, so you know, adjust your results as needed. So that's it for this one. Consider giving this video a like or a comment or subscribing to my channel. It super helps, and it helps support free math on the internet. And I will see you guys next time.